researching that, start kind of getting some different articles and whatever it is that you need to make that happen. All right? So get rolling on that. Number 2 today, Mitch at 10 o'clock in Whiteman Gibbs is doing a presentation on video fluoroscopy. It will be very interesting for you guys. So I would recommend attending. If you attend and write a reflection, I don't believe there's going to be much of an opinion. He is demonstrating a tool to use. So the reflection really is, what did you get out of it? Okay? So that's all you have to do, and then just email that to me. All right, in the subject line, in the subject line, just write Mitch. And that's what I'll look it up as, just in case they get lost. Yeah?
Are you going to have more extra credit opportunities throughout the semester?
Probably.
Okay, cool.
I'll try, yeah, as stuff comes up. So this is today. All right, so I really probably need to get out of here by 10 till, because I need to get over there with my sign-ups. I have my 101 classes can come as well, and I'm just trying to be there as Mitch's colleague to support him. So that is the plan there. Trying to think. That might be it. So we're going to try to make it through today, through the fats. But I won't rush it. I do know we have a little bit of time if we go into Monday, hopefully just a little bit if we have to at all. Okay, see if I can make sense of my mess here. All right, so a couple of things before I move into this. So one of the things to think about whenever you are working to, yes.
So the research project that we have on the board there, is that the controversy research paper?
Yeah, and actually I think you may have, I got the wrong one on there, so you may have printed off an early one.
Okay.
It is changed in the new schedule to nutrition research and nutrition for athletes. So it either says controversy, it used to be a controversy paper that we used to do, but I wanted to make it more practical this year and thought it would be good to have some guidelines for the coaches.
Okay. Does that have the requirements on it, like how long it has to be and whatnot?
That is in the syllabus, but actually, I will make sure when I post the specifics for each one, we really don't want it super long because we want them to read it. So we want it to be applicable. So instead of saying, it used to be, okay, a 5-page paper, your list of references, I still want your list of references after each section. I think we will make sure the list of references is there or at the end, however Carly wants to set that up. She is going to be the one to pull all of your information together into one document.
Okay.
All right, and so we'll kind of start with the general stuff and then move through some of the more specific.
For the labeling thing due Monday, do you want us to write what we see, or?
Yeah, it can be very, very informal. It really is just what did you go and, where did you go, and then just jot down things that caught your eye. Maybe look at ingredient lists, look at different labels, look at what the marketing people are telling you that this product does. Okay? Very informal. It can even be handwritten if you want. But it will need to be submitted into Blackboard. I will make sure there's a spot for that there. So you may have to type it up, but do it, yeah. Or you can scan it in your handwriting. Okay? Anything else there? Are we good on the business part? Okay. So when you try to reduce something in your diet, the biggest thing is what are you then replacing it with is going to make the difference. So if you are going to reduce the amount of fat that comes in your diet, what you replace it with makes a difference in the response to what is happening whether it is with good carbs or with, you know, junky carbs. So if you're replacing junky fats with junky carbs, that's not going to help you out at all, okay? So whatever you replace that with, so if you're an endurance athlete and you're like, you know what, I am finding that I need to do more carbs, so I am going to reduce some of the processed fats that I'm getting in my system, reduce that and increase, you know, choosing to increase it with fruits and vegetables as opposed to the processed carbs is probably the biggest thing. I also like, in your book they talk about this too, the whole food approach. Instead of looking at the different nutrients and getting really caught up in, okay, you know, I need this much of this much of that, this much of that, which, you know, elite athletes kind of have to look at that. If you kind of go to the end of the continuum, I don't remember which end I put the good foods on, I think it was down here. If you go to the end of the continuum where you are eating good, healthy foods, and they are giving you all of the macronutrients, that is really kind of the scope that you need to look at. And they found that when they were looking, kind of near the end of the chapter, in my book it's 207, and I'm trying to see where it is. Anyway, they went into, I can't find it. Basically saying in some of their research, when they started looking at different diets and how people were keeping track of things and what they were doing, those that just concentrated on getting the good whole foods, that was where they saw the biggest change. Okay? So that's important to think about, and I was excited because it kind of matched my philosophy anyway. And for those of you who went to the nutrition thing, thank you. And also find out that, you know, which you guys knew, those of us in the field, the lady who spoke did a phenomenal job. Whoever has vegetarian, she might be somebody to connect with, or with Mitch, or with, I don't know her real name, we call her Red. They are kind of in that scope of eating. So they would be some good people, but she did a great presentation on that. Most of our philosophy matched. There were a couple differences, which you guys were quick to point out, but that's okay. You know, you have to go by what you know about the human body, what your experience is with that, and then how you're going to live, and to remember that everybody's individual body is different. But for the most part, I mean, it was pretty good. I wish I had videotaped it. I thought of that as I was laying in bed that night. Like, oh, I should have videotaped this. But anyway, it was a really, really good presentation. So if that is your topic, you may want to connect with her. She is the dietitian for a hospital, I want to say in Eaton Rapids-ish, some type of a medical center there. Okay, but it was really good. Okay, so is there anything else here? I think we're good there. All right. So how are fats? Maybe if I can get to the right page. How are fats absorbed? And you guys, you'll have to bear with me. I played 6 games of ultimate frisbee yesterday, and then did a martial arts workout last night. And I can hardly move. So if I crumble up here, you'll know why. But that's okay. We'll make it through. So this figure in my book, this is figure around 5'7", 5'6". And all of messing up, I really haven't put my notes. Okay. Okay, so on this figure, you take a peek at that. Just a little bit of digestion takes place in the stomach. What happens is due to lipase enzymes that are released from the pancreas, the fats are digested into the monoglyceride, so it's broken down into the smaller fats, and the free fatty acids. All right, so that is all due to the enzymes that are released from the pancreas there. In the liver, bile is made, and this bile is very, very helpful for the digestion of fat and to help it be absorbed. So we've talked about the chylomicrons that fats are broken down into. So this happens, and then it is transferred into the lymph. Okay, so you can also see figure 5A shows this. You can see what is going on here, all right, as it's transferred in there. And then usually less than 5% of fats are excreted in the feces, which means most of it is going to be absorbed into the body. That is something to think about, okay? That what you eat is going to be absorbed into the body. All right, so you have to go through that process. All right, but that's just a really good background on kind of what is happening for fat to be absorbed. All right, so it's not happening necessarily within the stomach, but just further along the process, and then absorbed through the villi of the intestines and then into the lymph. All right, lipoproteins, which you'll see in figure 5-7, these are what transport the fats. You have heard of these, and hopefully you remember about the difference between LDL and HDL. HDL are the good guys, healthy, happy. You think of happy heart with the HDL. What the HDLs do is they actually get the cholesterol from the tissues, send it to the liver so that it can then be broken down and gotten rid of. Okay, and so that is helpful in decreasing cholesterol in the body. Now, the VLDL, so the very low density in the LDL, right? These are the ones that do the transportation from liver to tissues. The VLDL, it focuses on triglycerides, and the LDL focuses on cholesterol. Okay, so think of lousy, right? This is the one that we don't want. We want to decrease LDL and increase HDL. Now, within the body, LDL is generally at a higher ratio to the HDL. There's more, but the point is to get the HDL high and to bring the LDL down. All right, but the ratio is generally more LDL to HDL. Okay, and then lipoprotein A is similar to LDL, just in its makeup. And but there are different types. If you read through that, the different types of the lipoproteins that are there that work to do the transport. That is what they do. Okay, they're doing the transport. The HDL just happens to help to transport it out of the tissues. The LDL helps to transport it into the tissues. All right, and if you look at figure 5-9, it goes into some of the different types there. Okay, so that is actually figure, or is that figure 5-9 in your books? Okay, mine, I have an extra figure somewhere, so I don't know which one is extra. Mine is actually figure 5-10. And so, I don't know what that looks like, but intake of dietary fats. Okay, so we're looking here, in this, we're looking at cholesterol, we have free fatty acids going on, the glycerol, which remember is part of making up that fat, and then the phospholipids, which you generally find in the cell membranes, okay? You're also looking at some proteins, and then the different types of lipoproteins are what we're looking at here. So the dietary fats come in. In the small intestine, what's going to happen is this lipase, the bile is going to come in because that's what is needed in order to be able to break down fat and to absorb it, right? So it breaks it down into, you have the free fatty acids, then the glycerol, you have the cholesterol, and you have the phospholipids, okay? These are all part of fats. This is what is going to be available then for the body to either use or to store, okay? And with the small amount is excreted, but very little. So then for the intestinal cell wall, all right, now you have all of these plus protein, all right, and then it is sent out and it is going to end up, it gets broken down in further than those chylomicrons, so those are just like little particles. It's either sent to the muscle or adipose cells or it gets sent into the blood. Those are your options. In the blood, if getting sent to the liver here, you can kind of break it down further and kind of configure it. And remember, here in the liver, you can also, the glycerol can also be used to create a carbohydrate, which could be used for energy that way. Okay, so that is all happening there in the liver. All right, in the muscle or adipose cells, you have the free fatty acids and some of the glycerol, and those can be stored as triglycerides, or they can be used as energy there. All right, and we'll talk about specifically how that happens. So in the liver, then it goes back into the blood. The lipoproteins, so those will then are working to transport. All right, and then some of this may end up back as storage. It may end up back as energy, or it could be used in the structure of the cell. Okay. So the fats are kind of sent all over the body to be used in different ways or to be stored. If there is an adequate amount of fat already there to be used, the rest is going to go into storage. And that's kind of where you need to process, the amount of fat that you are intaking. Another problem with the storage of fat in the adipose cells, this is also where toxins are stored. Okay, so the greater the number of fat cells that you have, the greater the potential for toxins to be stored in the body. And in the environment we live in, those come in a lot of different forms. Those can interrupt different processes. And in every individual, it's going to come out differently. The increase in chronic illnesses and, some of the other health issues that we have. Okay, moving into a little bit of an opinion based on fact, have a lot to do with the toxins that we are exposed to in our environment, in the foods we eat. And so the greater the number of the fat cells, the greater the toxins that are stored in the body. And so when you are working with someone who has a chronic illness, one of the things, and they're overweight, one of the things you have to be careful of is how quickly they lose weight. And this is really intriguing because as fat is then lost and released, it also releases the toxins. The body still has to be able to take care of those. Okay? The body has to be able to break those down and get rid of them. So that is a little bit of kind of an opinion statement, but I believe it's based, I've listened to a lot of wise people who know a lot more about the body than I do, talk about how this happens. So something else to think about, and this is why people who have some of the chronic illnesses, especially some of the autoimmune, may be overweight, and it's kind of a vicious cycle of exposed to these toxins, the body can't get rid of it, and so it stores the fat to help be able to store the toxins so it's not floating around the body. So it's the body's protective mechanism that's helping there. Okay, we'll get off that side note and move on. All right, so speaking of toxins in our food, so they thought it would be really cool to trick the body again, just like they tried with diet sodas and stuff, because that worked really well, right? Is to substitute fat and trying to give food the flavor without the calories. So instead of your low-fat food being filled then with sugar in order to keep the taste up, they thought, well, what if we try a fat substitute? The problem here is that they do not break down in the body. And so, especially with Olestra, people end up with intestinal cramps, diarrhea, all sorts of things, because if it's not being absorbed, it then has to be excreted, and the process, it messes everything up, all right? I would tell people, and you're also, where are fat substitutes being used? Processed foods, right? So we're back to the whole thing of eating real foods as opposed to having processed foods but substituting with the fat substitutes. I also think of this with some vegetarians, and I have seen this firsthand. People want to move into a vegetarian diet, but in their regular diet, they ate a lot of processed foods. Instead of switching to plant-based, which is why I like what this nutritionist had to say, and I like what Mitch and Red kind of focus on is the plants. It's a plant-based thing. They aren't looking to switch from one bad diet to another bad diet just without meat, right? They're looking to focus on the nutrients found in plants and go from there. So, be careful here. And when you are advising your clients down the road, or your patients or athletes or whatever, really get back to talking to them about, okay, if you're going to have that treat, just have the treat with the fat in it and move on. All right? But just don't do it very often. People, I think, okay, well, if there's a fat substitute so I can eat a lot more. I think there's also a mental thing when you have this. And you have to be very, very careful with it. Okay? And I would have to venture that there's not an effectiveness with weight control unless you consider that diarrhea is going to probably cause some weight loss, but it's not going to be a healthy weight loss, and it's not going to be sustainable. So anyway, that is my 2 cents. Anybody have comments on this? Thoughts? What do you guys think? Since I'm giving my opinion, you guys can maybe give yours. Yeah.
What do you say there's a problem with, was it Simplex?
You know what? To be honest, I don't know a whole lot about that. I would have to research that a little bit more. I know most about Olestra because that's what I looked at the most when I have done research, and it didn't look as good. So, so to be honest, I don't know a whole lot about Simplex. Do you have experience with that? No. Yeah, so I would have to look into that a little bit more. All right. Okay, so here's just a picture of it, kind of showing the difference, you know, in the molecules that you have. I did want to say, I wrote some extra stuff down. Yeah, so it does, another thing that the fat substitutes, I'm going to just say Olestra because that is what I have focused my research on, is that it interferes with absorption of other fat-soluble vitamins. Okay, so not only, you know, are you, so you're replacing the fat with something your body doesn't recognize, causing issues in your body, and also interfering with absorption of other vitamins. Okay, so being converted to carboprotein, fats cannot itself. We talked about that the glycerol can be converted to the carbohydrate, and the carbohydrate can then be stored as fat. All right, but fat itself cannot. So this is just, you saw this when we talked about carbohydrates, looking at kind of how we end up with energy. And just remember this, that when fat is used as energy, there needs to be some carbohydrate present in order for that to happen. Or else you will end up hitting a wall. Okay? So there does still need to be some carbohydrate there. this just shows you a little bit how that energy ends up coming out from there. Okay, so fat is an energy source. Fat can only produce energy if oxygen is present as well. So this would be in more of your endurance type of athletics, so the longer runs that are slower, okay? And at rest, it's a higher percentage of fat that is being used at rest, okay? And a lot of this is with the brain health, with the nervous system, right? That's where you're gonna find that. And so on your page 183, it goes into kind of the byproducts of the metabolism of the fatty acids are the ketones, and this occurs when carbohydrate is low, okay? And that byproduct moving into ketosis is what they say kind of blocks energy from being produced. Now, it is, I don't know enough about this to understand, the thought. There is a thought out there, and we hinted on this in the carbohydrate, that if you get rid of carbohydrates, you increase the fat, that you can use the fat for more of your energy, and it would work better. But yet, then we're moving into this saying that, oh, that actually, then fat isn't as efficient to use. So there's kind of a play going on here. With my knowledge of the human body and my experience, I would say, still focus on, especially if you're trying to perform at a level and you want success there at a higher level, then carbohydrates is the energy source that you are going to need in the system, okay? That is my belief on that. That's kind of the side of the fence that I fall on. Okay? So we can store fat. Now, here's the thing about it. We have, there are 9 calories per gram of fat. So it's kind of more dense than you would say like the glycogen stores, because you're getting those 9 calories. So you have this energy that is there to use. But, up till now, we're still arguing about how to make that happen most efficiently. So the average American, or average adult male, has enough fat stored as energy to run 3 marathons, 80,000 to 100,000 calories. We all know, though, that there are elite athletes that at some time or another probably hit a wall, right, and weren't able to use these stores. And probably in our elite runners, they would not be an average adult male. They would have less stores to start with anyway. So there are a lot of other issues to talk about there. Most fat is stored in the adipose cells. All right, so you have 2,500, 2,800 about fat calories then that are stored in the muscle cells. Okay, so most of it is stored in the fat cells, and then you have some that are stored in the muscle cells. Right? But, once again, you need the fragments of the carbohydrate in order to be able to burn fat for fuel, okay, or you go into ketosis. Now, that goes back to, okay, the thought is if we train in ketosis, can we then use fat better? So those are some of the thoughts of why, they're experimenting with that to see if that's possible. So, let me see here. When we are looking, another thing that we can think about, the density of fat compared to the glycogen stores. When glycogen is stored, there are also about 3 to 4 grams of water per gram of glycogen, if I'm saying that right. That would actually be for protein or carbs, 3 to 4 grams of water, whereas fat doesn't have that, okay? Which is why we are able to use, when you get on the scale and it tells you your body fat percentage, what it's doing is really checking kind of the water level of your body, and the fat cells don't have the water where your muscle tissue does. And so there it can look at the body composition based on that. So that is actually how we're able to do that. Yeah, I think that's it there. So what is it then, when we are exercising, what does that look like? First of all, during rest, 70% of the fat that you have is esterified. During exercise, only 25% of it is. So when you start to get into the exercise mode, the fat is being used then as energy at that mild exercise level, okay? So this is pretty low, 25% VO2. You know, 80% of energy most likely is coming from the fat, all right? And most of the free fatty acids that then are floating around the blood that are getting ready to be used comes from the adipose tissue. As you move up in intensity of the workout, then it kind of balances out. The glycogen stores are being used, and then also it switches to the muscle triglycerides that then are being used. So now we're talking about that moderate exercise. Okay? Once you get kind of up to, so probably 65, up to the 85%, which is generally, you know, the highest that we should be working out is right in there. Not necessarily, but kind of in that area. As it approaches at 85%, that shift is happening. Fat use for energy is coming down, and carbohydrate use for energy is increasing. Okay, so your muscle glycogen stores become the main source. All right. So as carbohydrate oxidation is increasing, free fatty acid oxidation is decreasing as you are getting up to the higher levels of intensity. Now, but do you guys remember, those of you who were in 153 though, when we talked about percentages? At the mild exercise, so the thought process has kind of been, well, if that is where fat is used the most, then that's where I should exercise in order to burn fat. But your number of calories that you burn are less there. So even though the percentage of fat being burned is higher, the total number of calories is less, right? As you get up into the higher intensity, the percentage of fat being burned is less, but it's a higher number of total calories that are being burned. Okay? So you can kind of see how, you know, when you hear somebody say, well, don't do high intensity training because you're not going to burn fat. You are still burning fat, okay? And due to kind of the stress that is put on the body during that high intensity, what we call like the afterburn of the exercise continues for a lot longer, okay? So the metabolism stays higher after those. So I'm a very big advocate of high intensity interval training, especially for people who want to lose weight. And you can set those up in a lot of different ways. It doesn't have to be with really stressful, strenuous stuff on the body. You can do high intensity exercises in a lot of different manners. Okay? Let's see here. I have here figure 511 and table 5.5 to look at. So table 5.5 comes first in mind. So this just goes through fat energy sources during exercise. That really, it comes from the plasma, free fatty acids, at the lower level of VO2 max, and then it will switch to the muscles. Okay, so the triglycerides that are stored in the muscles. So that's just kind of a way to take a peek at that. I do not, maybe I'm wrong on the. Oh yeah, so when you look at fat being used, this just shows how the triglycerides get sent out into the blood. You have the glycerol, you have the free fatty acids, and so the glycerol gets sent to the liver because it can then be made into carbohydrate, right? So you have that breakdown that's happening, and then the free fatty acid gets sent into the muscle cells, into the mitochondria, so that it can be used. And we'll talk about carnitine in just a minute. That is the amine that is necessary to help get the fat where it needs to be and start the breakdown process. Okay? All right. So our trained muscles, they do burn fat better. All right. As you and go ahead and look at this table. This is a great table. Table 5-6. So when you are increasing use of fat as an energy source, these are all the things that are happening. Okay. Your blood flow increases, right? And even